The coronavirus has swept the globe, bringing our systems of everyday use into disarray. One of these is our public transport system. This project aims to find a solution for viable and safe public transport usage in a COVID-19 and post-COVID-19 environment. Within our public transport system, an area of high contact among passengers is train seating, more specifically, the upholstery. Sat on millions of times daily, they pose a significant threat for hosting and spreading not only COVID-19, but many other illnesses and bacteria. Seat upholstery is an area known for being dirty and unsanitary. I aim to create a short-term, quick response solution to aid in reducing the spread of COVID-19, as well as a long-term solution to aid overall hygiene and interior cleanliness within trains. For the public, the greatest fear behind COVID-19 is being unable to see it. The uncertainty that it may be around us while not being visible creates extra anxiety. That's why in this project I will treat surfaces as an interface, allowing the potential for infection to be visualized. In particular, I've chosen the train seat as an interface people can see and interact with. This was the first goal of my project. The second goal is to eradicate the risk. How can the risk of contracting COVID from a train seat be removed? Firstly, to make COVID visible, I began exploring interactive materials and technology. This is where I discovered thermochromic materials. In such materials, a dye is added which causes a color change when heat is applied. Secondly, to eradicate the threat of COVID contraction, I discovered a process called photocatalysis. Using a chemical compound as a catalyst, photocatalysis causes harmful molecules such as coronavirus to mutate into unharmful molecules such as water and salt. With these two innovative technologies, I've designed a solution that ticks both boxes. Do Not Sit Here, an interactive seat that will warn people when seats have been recently used. At the same time, it will also remove the possibility of contracting COVID-19. Thermochromic materials have an ambient state of temperature below 27 degrees, and a Leuco state, above 27 degrees, where a color change will take effect. The sign, made from open cell SBR with a thermochromic dye added, is glued to each seat. When a passenger is seated, their body heat will create a color change effect. Once the passenger leaves the seat, the Leuco state will display the message "Seat is self-cleaning." Once the temperature cools, it will return to the message "Seat is clean." The antiviral coating will also come into effect once the person vacates the seat. Within 1 minute, the seat will be clean and safe to use. With the two solutions paired together, the thermochromic message will allow people to see which seat is being sanitized and which are clean for use. For a long-term and post-COVID implementation, a complete revamp of our train seats upholstery is required, with the thermochromic material integrated directly within the seat's upholstery fibers. While this project focuses on trains, the application of the same method to other transport seats is also possible. Do Not Sit Here, an interactive solution for safer and cleaner travel.